Hi, and welcome to this video about closing a handle in another process. Normally, when we call the close handle API, we can close a handle in our own process. Close handle is unable to close a handle in a different process. Is it possible to close a handle in a different process? And generally it is, and there are two basic ways to go about it. The first option is to inject some code into the target process and then call close handle from within that process. Of course, assuming we know the handle number, the handle value. But that's pretty difficult to do, not just because of the technical aspects, but mostly because you need a very powerful handle to the target process to be able to inject code. Fortunately, there's a second option which is much simpler, using the duplicate handle API. Normally, this API is about duplicating a handle from one process to another, but in fact, it has a flag you can specify, which is called duplicate close source. This allows you to close the source handle when performing this kind of duplication of sorts. So essentially, duplicate handle can just close a handle in another process. Of course, you still need to have a powerful enough handle to the target process, but it's not as powerful as you might need for code injection. Let's see how to do that. So back in a previous video called the single instance application, we've seen that there's this behavior for Windows Media Player that it has a single instance as long as there's a mutex with a particular value, particular name to be more precisely, that is being used by that process. And the second process that may be launched sees that this object already exists and then shuts down. So let's see if we can close a handle in a media player process or any process really without having to go through Process Explorer, but doing that automatically using code. So let's create an application called close handle, not very imaginative, but good enough. And we'll start as usual by adding the proper include for Windows.h and also stdio if we have to write something using printf. Now we can go ahead and remove all these junk code here. So I want to get into the command line here and I want to receive two parameters, the process ID to use and the handle to close in that process. So we need two parameters on the command line. And remember, there's the first parameter, which is always the executable path. So let's say the usage here is close handle with the PID and the handle value itself. That's what we expect. If we don't have enough parameters, then we'll just bail out. Now we need the actual information. So the process ID, let's grab that. And we can use the A to I function to get a decimal value, but in fact we can do it a little bit better by using str2l to long function, which also allows us to provide values with hexadecimal numbers, which is kind of nice. And so I'm going to provide the string, which is argv1, and then this pointer represents where we'd like to end, or what would be the end of the string after parsing the part that was actually parsed, and I don't care about that. And the radix, that's the base to be used, we can use 0 for letting the function decide for itself. And with 0, if you have the 0x prefix, you can use that as a way to represent 64-bit number. Now we need the handle itself, so let's do exactly the same thing in fact, and just provide argv2 here. Now we can go ahead and give it a shot. So the first thing to do is to open a handle to the process that we want to close a handle which is just there. This is where that handle resides. So we need the process dup handle access mask. That's the only thing that we need in order to be able to use duplicate handle API, which is what we're going to use here. And the process ID, of course, is what we get here. If that doesn't work out, then there's nothing we can do really. We can just say error opening process. This could be because the process requires, we can't get process dup handle for that process, or it could be the case that the process ID is just a bogus process ID and doesn't really exist. Once if we have a process ID, we can proceed with calling duplicate handle. So we need to call duplicate handle. Let's see. So the first thing we need is a source handle, and the source handle is the one we're after. So that's going to be handle. I just need to cast that to a handle type. Let me just do that here. Just to make it simpler, let's go ahead and cast that to a handle. We might need to have some further casting here to turn a 32-bit value into 64-bit value, but it doesn't matter that much. It's mostly for making the compiler happy without actually changing anything. So first, the process handle in question is hprocess. The source handle is exactly handle. And then the target handle, the target process handle is our own process. We're going to use get current process here as a way to represent my process. Let's start with that. And then the target handle is going to be something we're going to get back duplicated into our process. Let's just use handle here with htarget, like so. So we have the target handle as a result, hopefully. And then we need to provide an access mask, which we don't care about because we're not going to really be using this functionality that much. And then the inheritance bit is not important. And here's where the important piece comes in. That means duplicate closed source. That's the important thing to receive. Once we have that, if that works, then we can happily say success. Otherwise, we have another kind of failure on our hands, which could be anything. So let's say error duplicating handle. And that's not really all. There's one other thing we need to do in case of success. So in case of success, the right thing to do then is, of course, to close the actual handle, which is the handle that we got, the target handle, which is in our process, so that the object is able to die if indeed that is the last handle to the object. At this point, we can just close the handle to the process and we're done. Of course, it's not critical to close the handle right here because we'll also close this handle automatically. The kernel will do that once our current process will shut down. Okay, so let's try it out. So here's Media Player. Well, we don't really need Media Player per se. We need Process Explorer here to see what's going on in Media Player. So going to Media Player, here goes. Let's look up the appropriate mutex. I'm going to just filter to named objects to make it easier. Just so we can see the handle value really, because we only care about the value. So we know that it's a mutex. Let's look for a mutex. Here it goes. That's the one. So here's the one. It's moving around, but we'll grab it. Here it is. So that's the one we need, which is the value 188 hex. So that's something we expect to disappear after our code executes. So let's go ahead and give it a shot by opening a command window here and run that from the command window, even though we of course could run that from Visual Studio. So here goes, we have close handle. Just to verify, we need these two parameters, process ID and handle. Okay, going back to Process Explorer, let's make it always on top. It is, but it sometimes doesn't behave as expected. Let's just do that again. So now it really is always on top. And then we need to provide the process ID, which we see it here as 41036. And this is where using hexadecimal comes in handy because Process Explorer shows handle values with hex numbers, so 188. And here goes. So apparently we can't open the process with the appropriate access, or maybe we're having a different problem because 87 means invalid parameter. So something is wrong with the process ID perhaps, and indeed it is. It's just me missing here the proper ID. And now it succeeds, and you should see the handle becoming red and going away. So that works. That works as we expect, or as we hope at the very least. We can go ahead and launch another media player, and it should come up normally as we expect, and it does. So that's one thing, but do we really have to use this current process as the target? Turns out we don't actually have to do that. We can just specify null here, and null here as well, saying really we don't really care about the duplication itself. There is no duplication that we really care about. It's just about removing the existence of that handle in the target process, and that is it. So let's try it now. Let's take the second media player and do exactly the same thing, but this time with the updated code. So again, I'm going to find the mutex, which is going to be hiding here somewhere. So here goes. Where is the mutex? That specific one, of course, that we need. Here goes. That's the one. It has the value 188 again, but this is just coincidental. Don't take that as something that has to be. It doesn't. It doesn't have to be like so. But this is what we have. So again, let's try to find that. Apparently, we have very many changes here. So let me just use, instead of working with names, let's just stick with numbers. So that's perhaps less likely to move around. So 188, here's our mutex in question. So let's do this again. Of course, the process ID is now different. The process ID now is 10804. And let's do that. And it works as well. We should see the handle becoming red, and it does, and it goes away. So as you can see, what we need to do here really is just provide null here for the target process ID, the target process handle, and null for the target handle as a result. We don't need that in our application here because we are not really interested in doing anything with it, just about closing this handle coming from this process.